Okay, sorry. So for the recording, let me just say 0 to 15 non-rebreather, 15 to 30 pediatric rebreather, 30 pounds and up adult rebreather. For number 12, it said know what parts of the machine are measured in PSI, CMH2O, liters per minute, and I'm going to get into that now at this part of the lecture. For example, the flow meter. When you turn on your flow meter, it is delivering oxygen in liters per minute. So if I said, what is the flow meter measured in, you would put L/MIN. And for like the vaporizer is percent. So it's not like you don't just say put the vaporizer at 5, you put the vaporizer at 5%. Okay, so I'm going to go into the other ones here. Now the flow meter can also be measured in mils because sometimes you run below 1 liter. If you're below 1 liter, then you are technically at like 0.5 liters, which is 500 mLs. So liters and milliliters can be the same thing depending on how much you're running to your patient. You said number, which was your other number? I got 18. What controls the flow of gases in a rebreathing system? Those were the unidirectional valves. So when I talked about the diagram yesterday, I said when the animal, there's 2 valves, there's 2 circles on top of the machine. And when the patient inhales, 1 valve opens, and when they exhale, the other valve opens. Every time they breathe, it'd be this, 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 this. And so the and that's literally in the name, unidirectional, one direction. If those valves are not there, they could be inhaling and exhaling the same gases. So you need the directional valves to do that. Let me see, someone else put, do we have to put anything for 12? No, so I answered that one. The second part of 22. So this should be in your book, but you ventilate, the pressure that we ventilate the patient is 20 centimeters of water, which is CMH2O. So when you squeeze the bag, every time you squeeze the bag, you're going to look at that gauge, and you don't want to go past the 20 because then you're putting too much pressure in the chest. So when every time we bag the patient, standard pressure is 20 centimeters of water. And that's how you measure ventilation to your patient. So that's the second part of 22. For number 13, do we use a VOC at school? And I'm going to talk about that. Yes, we use a vaporizer out of circuit, which is a precision vaporizer. A precision vaporizer is always out of the circuit. So a precision vaporizer and a VOC are the same thing. So people use those terms interchangeably. Most of the time, they're going to call it a precision vaporizer, but it is also classified as out of circuit, which I'm going to explain in lecture today. Number 16. Jenna, you're fine. Number 16. What type of vaporizer is affected by respiratory rate? That is going to be a VIC, vaporizer in circuit, and I'm going to talk about that. I got to hopefully get to all this. So vaporizer in circuit, because it's in the breathing circuit, every time they breathe, Haley, I'll have to find out. That's an interesting question. Maybe there is. Every time they breathe through the circuit, the vaporizer is in the circuit, so it affects the concentration to the patient. Hang on. Kayla, could you type that out? I'm cutting in and out. I was staring at the screen, so I don't think I was frozen. I may have been staring at the screen. Let me type something real quick. And I thought I put this in the email, but maybe I didn't. Hang on. I wasn't talking, so I just typed. Am I frozen or can you guys hear me? I was having trouble with my phone and email earlier. Okay, so I just typed the breathing systems. I have no video. Let me try to switch my Wi-Fi. I just switched my Wi-Fi. Can you guys see me now and hear me? Is that making a difference? You can still hear me. Let me. I just tried to stop and restart the video. Can you see me now? Just black now. It may be taking a second to catch up. Let me try something. Can you see the picture of the notes? So you just can't see me, but you can see the PowerPoint. And oh, I'm back. Okay, we're gonna start because goodness, I don't know. My technology has been very wacky. Okay, so I think some of this that I'm gonna talk about is gonna answer some of your questions. So all I want you, okay. Hopefully this works. Do you see me waving? Nope. Okay, let me try something. Yeah, I think I am gonna have to just talk because we have to. Okay. All right, I will say the name of the slide as I talk. So slide number 20 just shows you the picture of the machine. Below in the gray, it tells you what everything is. So the A are the oxygen tanks, B is your vaporizer. Up at the top here, and this letter A up here are your flow meters, okay? That little circle there is your pressure manometer. That tells you what you're bagging your patient to, which is in centimeters of water. If you look here, at the top, there are two glass domes over letter C. Those are the unidirectional valves. And the two black tubing, one is the inhalation hose and one is the exhalation hose. But these valves at the top keep it going in one direction. And again, remember the video I sent you, he goes through a machine and explains all this. So it's a really good video. So I'm going to go through these different parts. The main thing is, remember, oxygen is our carrier gas. And on room air, oxygen is 21%. You would have to run at least, yes, I'm recording. Thank you for reminding me. You have to run at least 30% to maintain metabolism. You are running 100% oxygen. So we're more than meeting metabolism, but they are used to carry gas. Now, there are two types of tanks that I want you to know. They hold oxygen under pressure. E tanks are small. H is big. Think H is huge. H is huge. But H tanks are very large tanks, and they are usually kept like in a closet in the back of a clinic, and then lines are run through the ceiling. And if you go to a practice and you see a green hose coming out of the ceiling, that oxygen supply is drawing off of probably a bank of H tanks. So usually when you have multiple tanks in a row. Now the machines at school, if I go back, do you see these two little tanks? Whoops. And they are attached to the machine. Those are E tanks. At school, well, yes, and that's a good way, Miranda. It's like these little this enables you could take this machine anywhere. I could go anywhere in the hospital and I have my oxygen with me. So it is portable. Oh, you watched the video, yay. I forgot that he said that, to be honest. But when you use an E-tank, this is what you guys will have at school. Very important to know, one tank should always be called in use. It's the one that's open and being used. The other tank on the machine should be full. So you always want to have a backup tank. If you are the last one to use that tank and it's empty, you need to remove that tank, put on a new tank, and then mark the other one in use. So you always should have one in use and one that is full, that has not been used yet. So those are the two types. You will have a control valve somewhere at the top. Remember, righty-tighty, lefty-loosey. If you turn it to the left, that opens up your oxygen. If you turn it to the right, that's going to turn off your oxygen. And then remember, somewhere right after the valve to open the oxygen, it's usually right next to it, there is going to be that pressure. Well, there's the gauge that tells you how much oxygen is in your tank. That's first. So when you turn it on, you need to see how much pressure is in your tank. Right after that, you have a pressure reducing valve, remember, that slows it to a workable pressure, which is usually 50 PSI. And it's not in the notes, but so 50 PSI is safe for the anesthesia machine. And again, that is not something that anybody should mess with. The pressure reducing valve is usually set. There is a little dial on it that you can adjust that pressure, but once it's set, it needs to stay at 50, okay? They're showing you the difference here. You see A, that's an H tank, and the one down here is an E tank. And oxygen is green. Oxygen is green. Think green for life. You need oxygen for trees and grass. So green means life. Now here's an example of the H tanks, and they are all strapped to the wall. And then if you look up here, they're all connected. Up here, one of these gauges would tell you how much pressure is in the tank, and the other one would tell you your reduced pressure. Now, one thing to look at is these different color tags, okay? It's hard for me to see on this picture, but one says empty, one says full, and one is in use, okay? So you always have the tank you're using. You should always have a backup tank, maybe multiple backup tanks, and then your empty tanks. Every time that it's empty, you have to mark it. You have to change the tag. Usually wherever the oxygen is kept, we have tags. Then I would just, if I emptied a tank, I would put a hook on the tank and it would say empty. That way someone knows that. Well, what happens, Haley, is technically you cannot like completely take them off, but you can turn off one tank and turn on the other. That's the way we have the machines at school. But yes, if you were to take one off, you would have to completely turn off the flow meter. So there would be a time where oxygen wasn't going to your animal. But you can turn one off and turn the other one on. That's why you always want to make sure when you're the anesthetist and you have to check your machine in the morning, make sure you check your machine, your tanks, before your patient is hooked up, because you want to know that you're starting with enough oxygen so you don't get in that trouble. But I've had people empty a tank and not change the tag. One tank ran out and I went to turn on the other tank and it was empty, and they never changed the full sign. This is when I was at Purdue. So that's why it's essential. Yeah, I had to go running for another tank. We had to disconnect the animal, use an ambu bag to bag them, and I had to run for another tank. So, and I was taking over a procedure for someone else. So I had never, this is the other thing, guys, is, that's my bad. I was in the middle of a procedure and I took over. But if someone else checks your machine for you, if you're the one doing it, it's on you. So you have to make sure that you know that it's in working order and that, you have everything you need. Now, these hoses in the ceiling, so this would be like in the ceiling, and you'd look for the green hose. You would hook up the anesthesia machine, you would pop it in the green hose, and then it would draw from these tanks. So usually in our hospital, these tanks were always on because we were a 24-hour emergency hospital. So you needed oxygen at a moment's notice. If you're in a general practice, you might turn these off at night, and then you have to remember someone has to turn them on in the morning. Like, you guys will turn off your little e-tanks at the end of surgery. But a lot of times in a bigger hospital, oxygen is always on. Now, if no machines are on, it's not being used. It's just on and ready, if that makes sense. So this would be a quick release where you pop the hose. Yes, Michaela, I don't know if you look at this picture here, yellow is compressed air. So some ventilators and some power equipment use it's kind of called medical air, but it's just compressed air. And that's a yellow connector. Black, I think, is nitrogen. We use nitrogen tanks to power our surgical drills. So that was a black tank and a black connector. So they are color coded. You cannot hook up an oxygen hose to a nitrogen drop. The pin is different. So besides color, the pin setting doesn't allow you to hook up the hose in the wrong location. So if you're half asleep and you're trying to push into this yellow connector with your green hose, it's not going to work. So exactly, which is nice because, everybody has their days. Here's a picture, and maybe you can see it. Well, first of all, D is the line pressure gauge, and you can see it's at 50. That's telling you B right here is your reducing valve. So C, right now your tanks look like they're at about 1,000. So you have 1,000 PSI in oxygen. B is going to slow that down, and now D is telling you you are at a 50 PSI. So that's what these gauges are telling you. A is just the connector of the line to the tank, and E, this is the righty-tighty, lefty-loosey. This is how you turn on the oxygen. Okay, so you have oxygen, line, or pressure of your tank pressure gauge, pressure reducing valve, line pressure gauge. Not every machine has a line pressure gauge. Some will. So if you see two gauges here, you just need to know the difference between the two. Okay, now what I want to show you here, this is what you will be looking for when you guys go into surgery. This is an E-tank down here. If you can look at, you have H is a little tab that you pop off, the new tank. Do you see that D and E, it's a hole and two little holes. That is the pin connector. And then this thing right here is the yoke. So what you're looking at right here, if you guys have heard of male and female connectors, like when you work with fluids, they'll tell you there's the male end and the female end. And that's kind of just a term that we use for connectors. So basically, the tank has the female ends, okay? The yoke has the male ends. Now, F and G, do you see how there's 2 pins and then there's a solid pin here? They only fit in this tank. So you could not put a black tank, a nitrogen tank, a air tank, a nitrous tank. You couldn't put any of those tanks in this yoke because it only fits these pins. So if I asked you, how do we maintain safety with tanks? There is a pin coding system and there is a color coding system. So first match the color, but the other thing is the pins only fit, think of it like receptors, neurotransmitters. They only go to their receptor. Okay, it's specific. Does anybody not understand what I'm talking about? Now, when you go into surgery, and like I said, somehow next term, I'm going to figure out how to go through machines with you guys, like in the surgery room, like in small groups. So you will go through this. I will show you this and kind of show you also in your surgery rotation, McClure and Ritz and Dr. Paul, they'll probably go through it with you as well. So they will only fit an O2E tank, right? Because the H tank would be way too big to go under there. So the E tank is specific to that yoke. But I want you to know the yoke is on the anesthetic machine. You put the tank inside the yoke. So the yoke connects to the tank. It's kind of like, I think, when you have oxen and they hook onto the yoke for, you know, the cart, whatever. You definitely want to make sure that you turn it counterclockwise, which is to the left, and you want to turn it 3 or 4 times till it's open. As soon as you turn it like a half turn, you'll hear oxygen come in. You'll hear, it'll be like this blast of oxygen. You want to open it a couple more times, and then you should check your tank gauge to see if you have oxygen. So there is a little key. If you can see in this guy's hand, there is a key. There's a little stem on the oxygen tank, and you put the key, it's kind of like an Allen wrench kind of thing, but you put the key over and you turn the stem. Now, every machine in surgery has one of these keys on it. So it will, oh, okay, my PowerPoint is freezing. Hang on, don't leave the chat. I'm gonna have to reboot. It won't shut you down. Oh, wait a minute. Okay, it won't shut you down. I will be back. Hold that thought. Oh, wait a minute.